Okay, so now here's an example problem. You have 3x squared minus 4x, and you're given this formula, and you have to find the Fourier series of this function. Now, before I go on, I wonder if you know the integration formula for even and odd functions. So let's see, negative pi to pi of, say, x to the 99th power dx. What's this? 0. Why?
It's an odd function.
It's an odd function. That's exactly the thing I wanted. This is an odd function. So it's 0. What does odd function mean? If you draw this graph, it'll be like going this way and that way. One side goes up, the other side goes down. So if you integrate from on a symmetric domain, see, negative pi to pi is a symmetric domain. That's why we prefer negative pi to pi instead of 0 to 2 pi. In some books, especially engineering books, they like to use this for some time domain. For time domain, you don't use negative, so the formulas will be actually from 0 to 2 pi instead of negative pi to pi. Yeah. But in our class, I would like to do it from negative pi to pi because then we can use such symmetry. Okay. So if you have any x to odd power, it's an odd function, so it will be 0. And on the other hand, if you have integration from negative pi to pi of x to the 100, that's an even number. And what happens here is that they both go up. However, there's still a symmetry, which is the integral from negative pi to 0 is same as integral from 0 to pi, right? So you can rewrite this as twice of the integral from 0 to pi. And you might think, oh, you still have to do the integral, what's the point? But it does save you a lot of time because plugging in 0 is a lot easier than plugging in negative pi. You'll see. In practice, this actually does save you a lot of time. So we're going to use that. Let me see. So if you have cosine of nx, what do you think? Is this even or odd?
Even. Even.
Even, yeah. Well, why? Because I showed you the Taylor series of the cosine. It only has even powers. Whereas sine gives you only the odd powers, if you look at the Taylor series. That's one way to see it. Or if you know the cosine function, this is the cosine function, right? But if you extend it to the left, you see that the left and right, they fold together. They have a perfect match, right? So whether you integrate from negative a to 0 and 0 to a, you get the same value. So this is going to be twice of 0 to. On the other hand, if you have the sine function, then it's going to be 0. Because the sine function, one side goes up, the other side goes down. When this goes down, this goes up, right? So when you integrate from a symmetric domain from negative a to a, it will always give you 0. So that's a nice shortcut. You really want to use this property when you do the calculation. If you don't, then you might end up with some really complicated one and you may not be able to finish it in time. Another thing that you'll see is that if you have an odd function times an odd function, it will be an even function. Because it's like if you have an odd function times another odd function you integrate, what's this? That's x to the 12th power. So it's going to end up being an even function, right? So if you integrate that from negative pi to pi, it will be twice of 0 to pi. And that's still true even if this is a sine. Odd times odd will give you an even function. So these are some ideas that we're going to use to do the calculation, right? So keep that in mind. some professors do teach even and odd in Calc 2, but a lot of them don't. Sometimes I don't even have time to discuss this. How many of you have actually heard of this, even and odd? There's 2, 3, okay, 5, okay, about 1/3 of the class have heard of this.
Even not?
Even and odd, and then this formula for the integration. Okay. All right, so now let's do the calculation. Let's do the A0 first. Okay, so A0 is 1/2 pi, integral from -pi to pi of this function 3x squared minus 4x dx. Yeah, there's nothing to be multiplied, it's just by itself, right? X squared is even or odd?
Even.
Even. 4x, even or odd?
Oh.
Odd. X, the first part, it's odd. So if you integrate 4x from -pi to pi, you're going to get 0. But if you integrate 3x squared, that's going to be the same thing as you double integration from 0 to pi of 3x squared dx. And then 2 cancels, and you get 1/pi. And then 3x squared integrates to x cubed. So you have x cubed, you plug in pi and then 0. And then pi cubed over pi is pi squared. So that's what you have. Is that okay? It's okay, all right. Now, what about an? 1/2 pi, no, this is 1/pi, integral from -pi to pi, 3x squared minus 4x dx. And then, times, the formula says times cosine nx, right? dx. Okay. So we have to compute that. And it's a product of functions, so of course we will need to use the integration by parts. However, cosine is an even function. Even times odd will be an odd function. So we don't have to do this. We only have to do 3x squared times cosine x. Moreover, we can do the doubling trick, so it'll be like 2/pi, integral from 0 to pi of 3x squared cosine nx dx. Okay. And now you have to do the integral using integration by parts. But let me show you a method that I like instead of the integration by parts. How many of you have heard of tabular integration? Tabular integration, yeah. Okay. Did you learn it from Calc 2?
No, I just saw it online.
Oh, okay.
Yeah.
All right. It's my favorite way to do integration by parts. Any integration by parts can be rephrased using the tabular integration. Anything that you do with tabular integration can be done by integration by parts. It's the same thing. Okay. You can see it in many YouTube channels if you never have seen it. But let me give you a quick intro. What you do is, and if you do understand integration by parts, you'll see that the description I have is exactly the same thing. It's just the repackaging in a way that the calculation can be done quicker. Okay? So when you do tabular integration, you first have to have 3 rows. And the order is very important. You need plus and minus for the first one, d for the second one, and integration for the third one. Okay? If you mess up this order, it doesn't work. So you have to have it in this order. And then Liate says L is logs, I is inverse trigs, A is algebraic, T is trigs, E is exponential. So in our case, we have 3x squared. What's that? Algebraic, right? Polynomials are algebraic. How about cosine nx? What's that? Trigonometric. So it's like AT, right? So you put 3x squared here, because that's on the left side of v8, right? And trig is on the right side, so you put it on the integration column. And what you do is you keep differentiating until it hits 0. Okay? Sometimes it doesn't hit 0. In that case, you have to do some other things. That's why it's challenging sometimes. But you know, in most cases, you just have to know when to stop. Okay? But for polynomials, it's easy. You just keep differentiating until you hit 0. Okay? So 3x squared differentiates to 6x differentiates to 6 differentiates to 0. Now you have to integrate it. Cosine x integrates to sine x, but what's cosine nx when you integrate?
And sine.
Negative sign.
It's sine nx. No, it's not. If you
Negative.
integrate, it's positive sign. Okay? Yeah, it's positive sine nx, but then it's a reverse chain rule. Right? If you differentiate, n comes outside, but you're doing the integral, so instead of n coming outside, the 1 over n comes outside. Okay? Let's do the next one. What's the integral of sine? Negative cosine. Okay? So the differentiating sign gives you positive cosine, but integrating sign gives you negative cosine. So it's negative. Another 1 over n will come out because you integrated. So this will be 1 over n squared. And you have cosine nx. Integrate one more time, you get negative 1 over n cubed sine nx. And because this hit 0, you stop here. Okay? And then on this side, you always start from plus, and you keep filling in. So the next one will be minus, the next one will be plus, the next one is minus. Just like that. Okay? All right. Now, when this is not something that hits 0, then you may get something here. But for that, please watch the watch some YouTube videos on what to do on that one. I'll say it a little bit. All right. So you have this, and if you recall what you do for integration by parts, you do everything that I wrote here, right? What is integration by parts? You differentiate one and you integrate the other. That's what happens. At some point, the differentiated one becomes simple enough that you can just do the integral. That's the idea, right? So that's exactly what's happening. You're differentiating one of them, whereas you're integrating the other one. But to extract the answer from here is you go like straight across, but then you go like that. It's like a missile, something like that, right? Just like that. Good. Go straight down. And whenever you do that, you multiply the result. So it's 3x squared times 1 over n sine nx. And negative times negative is positive, so it's 6x times 1 over n squared cosine nx. And you multiply like that, so it's negative 6 times 1 over n cubed sine nx. Okay. And then if this is non-zero, there's an extra step, which is to go across this way, a straight line. It's different from the other ones. You go like that. But the last row, you go across this way, and then the multiply thing should be integrated. Now, in our case, because of 0, you're just integrating 0. What's the integral of 0?
Zero.
I'm constant.
Constant, c.
Oh, yeah.
Yeah. So this is going to create plus c for us. So the result of this integral is this plus this plus this plus c. But you're doing definite integral, so this doesn't, it's not needed. So it's just that, okay? So is that okay? Do you see the result? All right. This makes integration by parts very easy. here. So let's write down what we have. It's going to be 2 over pi 3x squared over n cosine n pi. No, what am I writing? Sine nx. Sine nx. I should be writing this one. Okay. So 3x squared over n times sine nx. And then plus 6x over n squared cosine nx minus 6 over n cubed sine nx. When you plug in pi and then 0. Okay? Now that looks horrible, but it's not that hard if you know that cosine n pi is negative 1 to the nth power and sine n pi is 0. Because if you plug in pi, that's all you're going to get, right? When you plug in pi, what's sine n pi?
0.
0. What's cosine n pi? Negative 1 to the nth power, right? What's sine n pi?
0.
Is 0. So, although it looked horrible, this is 2 over pi. When pi goes here, that's 6 pi over n squared times negative 1 to the nth power. Okay? And then when you plug in 0, sine 0 is? Sine 0 is?
0.
0. You plug in 0 here?
0.
0. So cosine 0 is 1, but because of this 0, it's going to be 0. When you plug in 0, sine 0 is? 0. You guys are not fast enough. Here's the sine graph, okay? Sine 0 is? 0. Just remember this graph, okay? Sine 0 is 0, sine pi is 0, sine 2 pi is 0, okay? Okay, so that's what we have, and then canceling this pi, and then 2 times 6, you have 12 over n squared times negative 1 to the nth power. Okay. Alright, so for the lack of space, I'll have to erase this one. Just remember that was our an. Now let's do bn. It's pretty much the same thing, boring stuff, but I just want to give you a complete example, so bear with me. There's one more calculation here. It's 1 over pi, integral from negative pi to pi, of 3x squared minus 4x times sine nx dx. Again, using the even and odd thing. Even function times odd function gives you odd, so 0. Odd function times odd gives you even function. So this is the one that is even. Now we use the doubling trick. So it would be 2 over pi. So it got doubled. You integrate from 0 to pi instead of negative pi to pi. So the domain got halved. And then 3x squared gone because it's going to create an odd function when you multiply. This one is the one that gives you an even function, so it would be negative 4x sine nx dx. Now, I don't like negative, so let's even pull that one out and write down negative 8 over pi, integral from 0 to pi of x times sine nx dx. Again, tabular integration, plus minus d integral x differentiates to 1, 1 differentiates to 0, sine nx integrates to negative 1 over n cosine nx. This one integrates to negative 1 over n squared sine nx. You plug in plus, minus, plus, do that, that. So you end up with negative x over n cosine n pi, and then negative times negative is positive, so it's plus 1 over n squared sine, what? Cosine nx, right? Sine nx. And then you plug in pi and 0. And when you do this, I see a lot of people forgetting this coefficient. Don't forget that one, negative 8 over pi. So that's going to be our Bn. And again, when you plug in pi, negative cancels, pi over pi is 1. So you have 8 over n times cosine n pi is negative 1 to the nth power. And then sine n pi is 0. When you plug in 0, none of these give you anything, so that's your Bn. Okay, so we got A0, An, and Bn for n1 or greater. And don't finish here. There's one more step. What's the last step?
Combine them.
We put them together to actually write down the Fourier series, right? So the final answer is this. The final answer is 3x squared minus 2x is now equal to A0 is pi squared plus summation of n equals to 1 through infinity of An is 12 over n squared negative 1 to the nth power, right? And then cosine nx plus Bn is 8 over n negative 1 to the nth power sine nx. That's it. Okay.
You just need to change to the negative 4.
What?
Oh, you just need to change to negative 4. 3x squared.
Oh, sorry. I don't know why I said negative 2x. So 3x squared minus 4x will be equal to this thing at every point from negative pi to pi, except for the endpoints. At negative pi and pi, because it's this, I don't know what that is. If you plug in pi, that's 3 pi squared over, so the value is 3 pi squared minus 4 pi, that's like 12 minus 27. So it's some positive value at pi. At negative pi, if you plug in, that's 3 pi squared plus 4 pi, that's like even higher. And I guess it's something like this, I don't know. It's a parabola that looks like this. And this side is, this side is lower than that one. So if you calculate the right side, the value at negative pi and pi won't be same as these, but it'll be like half of these 2 points. But everywhere else, if you do the infinite sum, it will give you the exact value of the left side. So that's kind of amazing that you can represent any function that way. So yeah, but it does work.